Okay, welcome to lesson number 2. Now we will talk about polynomials. A polynomial is a mathematical expression, okay? For example, 5x squared minus 3y plus 7. Here, the variables are x and y. The constant is 7, and the coefficients are 5 and negative 3. 5 is the coefficient of x squared and negative 3 is the coefficient of y. You will find some problems about addition and subtraction, just like number 1. This is all about combining like terms. Let's see. Which expression is equivalent to? So here we will first remove the brackets from 5x squared minus 4, and then you have to distribute here in order to remove the brackets for the second part. So that is plus 6x squared minus 3x plus 5. Next, we will combine like terms. 5x squared plus 6x squared make a total of 11x squared. Next, minus 3x, and at last, minus 4 plus 5 gives 1. So the answer is choice B. We have to apply distribution. So that is x cubed minus x plus 3x squared minus x. So what comes next is to combine like terms. X cubed plus 3x squared minus x, and that gives minus 2x. So the answer is choice D. For example number 2, distribution one more time, we get 4x squared minus 2x, and then 4 times 4x, 16x, and then 4 times minus 2, which is minus 8. Now, don't forget to combine like terms here. Plus 14x minus 8. So the answer is choice C. So this is the last example about multiplication. Let's see here. Here, for example, you're going to start by multiplying 2 by x minus 4. That gives 2x minus 8. And then you will multiply that by 2x plus 3. So we will apply distribution here. 4x squared plus 6x, and then minus 8 times 2 minus 16x, and at last minus 8 times 3, which gives negative 24. We will combine like terms as usual. 4x squared minus 10x minus 24. And this is choice A. Another way to solve this problem is the following. We will start by multiplying x minus 4 by 2x plus 3. That gives 2x squared plus 3x minus 8x minus 12. Next, we will combine like terms here. So we get 2x squared minus 5x minus 12. And at last, we will multiply by 2. 4x squared minus 10x minus 24. And as you can see, we will get the same answer. Addition and subtraction of algebraic fractions is another popular type of problem on the SAT. So let's see how it works. In order to find the sum of 1 over x plus 2 over y, you will do the following. Cross multiply 1 times y plus 2 times x divided by the product of the denominators. That's how it works. Now you get y plus 2x divided by xy. Now let's try the same with another example. 1 divided by x minus 1 minus 1 divided by, let's see, x plus 3. So you follow the same steps. Cross multiply 1 times x plus 3 minus 1 times x minus 1 divided by x minus 1 times x plus 3. So next we get x plus 3 minus x plus 1 divided by x minus 1 times x plus 3. And at last, we will simplify the numerator by combining like terms. X minus x gives 0 and 3 plus 1 gives 4. So we get 4 divided by x minus 1 times x plus 3. Okay, let's see now example number 1, which of the following is equivalent to the expression above. So here we will just again follow the same steps. Cross multiply, that is 1 times x minus 2 plus 2 times x plus 2 divided by the multiplication of the denominators. Now we will get x minus 2 plus 2x plus 4 divided by x plus 2 times x minus 2. Now we have to simplify the numerator, combine like terms. X plus 2x gives 3x, and minus 2 plus 4 gives plus 2. So see here, the answer must be choice B. Now let's see this second example. If x is greater than 1, which of the following is equivalent to the value of this complex fraction? So here what you have to do is first simplify the denominator. So you have to calculate the sum. I will do that here below. Okay, so we get in the denominator x plus 1 plus x minus 1. Now don't forget that we cross multiply. This times this guy plus this guy times this guy, and then we will multiply the denominators. So this is x minus 1 times x plus 1. Next, we have to combine like terms here. X plus x gives 2x, while 1 minus 1 gives 0. So we get 2x, and then here x minus 1 times x plus 1. Now, remember that the x on the top is divided by an invisible 1. Now I have to simplify the complex fraction, and what we have to do is the following. We will multiply x by x minus 1 and x plus 1, and that will be divided by the product of 1 and 2x, the two middle terms. Next, we can simplify, we can get rid of the x terms, x and x. X divided by x gives 1. So finally, the answer will be x minus 1 multiplied by x plus 1 divided by 2, which is choice D. Okay, this is the next topic of the video lesson, solving systems of linear equations by substitution. See here. Substitution is all about isolating one variable, either x or y, in the fastest way possible. Here, the fastest way will be to isolate variable y in the first equation, y equals to 5x minus 7, and substitute that here. We will replace y in the second equation. So that is minus 3x minus 2 multiplied by 5x minus 7 is equal to minus 12. Minus 3x minus 10x plus 14 gives negative 12. Then we will combine like terms. Minus 13 plus 14 gives minus 12. I will subtract 14 from both sides, so I get negative 26 on the right. And at last, divide by negative 13, so the value of x gives 2. Once you get the value of x, you can solve for y. Remember, y is equal to 5x, 5 times 2, minus 7, and that is 10 minus 7. So the value of y is 3. So here we have the solution. X gives 2 and y gives 3. That's how it works. Okay, this is now solving systems of linear equations by elimination. See here, elimination is about getting the same coefficients for one variable across the two equations so that you can add or subtract the equations, thereby eliminating that variable. Let's see, suppose you're given x plus y is equal to 5, while x minus y is equal to 12. If you add the equations, you will get rid of the y's. X plus x gives 2x, y minus y gives 0, and 5 plus 12 gives 17. So 2x is 17, and the value of x is 17 divided by 2. This is what we know as elimination. We combine, we add them up in order to eliminate one of the variables. This one is easy because you don't need to modify any of the equations. However, in this example, we need to modify at least one of the equations before combining them. See here. If we add them up, we will not get rid of any of the variables. And we need to get rid of one of the variables. So here we have minus 2y, and in the first one plus 1y. If I multiply the first one by 2, I'll multiply this one by 2, then I will get minus 10x plus 2y equals to minus 14. And now, if we add them up, we will get rid of the y's. minus 3x minus 10x is minus 13x, minus 2y plus 2y, 0 minus 12 plus minus 14 is minus 26. So minus 13x equals to minus 26. After dividing by minus 13, the value of x gives 2. And then we just solve for y in any of the two initial equations. I will do it with the first one. I just replace x by 2 in order to solve for y. So that is negative 10 plus y is negative 7. After adding 10 to both sides, the value of y gives 3. Out the greatest common factor. So the first step is to pull out the greatest common factor of 6x and 24. That's 6. And next, open brackets, 6x divided by 6 plus 24 divided by 6. So the factored form is 6 times x plus 4. And the next one is pretty much the same. We find the greatest common factor of 8x squared and 4x. That gives 4x. And then open brackets, 8x squared divided by 4x minus 4x divided by 4x. So that gives 4x times 2x minus 1. The next one, again, calculate the greatest common factor of 6xy and 10x squared times y. That gives 2xy, and then open brackets, 6xy divided by 2xy plus 10x squared y divided by 2xy. That results in 2xy multiplied by 3 plus 5x. And the last example below, you pull out the greatest common factor, which is m squared. You follow the same process. So m to the fourth power divided by m squared minus 3m to the second power divided by m squared. And that gives m squared multiplied by m squared minus 3, as you can see. The second type of factoring is factoring by grouping. So here, the first step is to group a pair of terms. So we will find the factored form of the first pair, and we will find the factored form of the second pair. The factored form of the first pair, of the first sum, is x times x plus 2y, plus the factored form of the second two terms will be 5x squared times 1x plus 2y. As you can see, we have found a common factor, x plus 2y, x plus 2y. So the last step is to pull out this new common factor, x plus 2y times what is left, x plus 5x squared. Now you can try the same here for ab minus 4b plus 3a minus 12. Okay, let's see. This is an example about factoring methods. Here we need to solve for y. So the first step will be to simplify the left side of the equation. Okay, let's see here. These are examples about factoring. In the first problem, we need to solve for y, so the first step will be to simplify the left side, that is xy plus 2x gives y. The next step is to put together all the y terms on one side of the equation, that is 2x equals y minus xy. Next, we will apply factoring. Y is the common factor, and then times 1 minus x equals to 2x. So finally, the value of variable y is given by 2x divided by 1 minus x. You can see. Now, in the second one, example number 2, we have to solve for a. So the first step will be to cross multiply. That is the strategy that we will follow. Cross multiply 2c times a equals to ab plus b. The next step is to put together all the a terms on one side. So I will subtract ab from 2ca. 2ca minus ab equals to b. The next step is to apply factoring. We will pull out the common term on the left side. The common term is variable a, so we pull out a, and then we are left with a times 2c minus b. So at last, variable a is equal to b divided by 2c minus b. At last, let's see, this is example number 3, which of the following expresses a in terms of b and c. So we have to solve for a. The first step will be cross multiply. So we get b times 3a plus c equals to a times 1, which is a. Next, we will simplify the left side of the equation. 3ab or 3ba, which is the same, plus cb equals to a. Now we need to put together all the a terms on one side. So we will subtract 3ba from a. And what comes next is factoring. We pull out the common term, which is a, the common factor, and then we get a times 1 minus 3b. At last, we will isolate a after dividing by 1 minus 3b, so variable a is given by cb divided by 1 minus 3b. And this is shown in choice A. Okay, this is another popular factoring method shown on the SAT exam, the difference between two squares. So a squared minus b squared is factored as a minus b times a plus b, or in the other way around, the sum multiplied by the difference. For example here, p squared minus 36. The first step is to express 36 as the square of a number. As you know, 36 is the square of 6. Now that they both are expressed as the square of a number, the factored form is given by the difference of the bases multiplied by the sum of the bases. Pretty much the same here. Remember that 121 is the square of 11. So 11 squared minus b squared in factored form will be 11 minus b multiplied by 11 plus b. And at last, here, so we get x squared minus, how about 9y squared? This guy, all of this should be written as the square of something. So we will replace that by 3y to the power of 2. Now that both are squares, the factored form will be x minus 3y multiplied by x plus 3y. Here we have an example about the difference of the squares and some other factoring methods. So let's see. We have to find the value of m plus n. So we have to isolate m plus n. We will focus on that. The first step will be to factor the numerator, and the factored form of the numerator is the difference of squares, so that is m minus n multiplied by m plus n. And next, we will find the factored form of the denominator. We will pull out the common factor, which is 2, so 2 multiplied by m minus n. Now, we will simplify. We can get rid of m minus n. As you can see, m minus n divided by m minus n gives 1. So we have m plus n divided by 2 is equal to 9. And at last, in order to isolate m plus n, we will multiply both sides by 2. So 2, 2, 2, 2. So finally, the value of m plus n gives 9, which is choice D. Let's see, this is another example where we... Okay, so this is another example of the difference of the squares. Let's see here. We need to solve for variable a. What is a in terms of x and y? Okay, so the first move will be to put all the a terms together. That is I will add ay to ax, and I will subtract x squared from y squared. Now, what comes next? What comes next is the following. We will apply factoring in both sides. On the left, a times x plus y. To the right, y minus x times y plus x. And at last, we will divide both sides by x plus y, so we can get rid of x plus y here and also x plus y here. Remember that x plus y divided by x plus y gives 1. So at last, the value of a is given by y minus x, choice A. Okay, this is not about factoring, but this is a special formula that you should be familiar with, the square of a binomial. And here we have the formula for the sum. A plus b to the power of 2 is given by a, like this is always in this way: a squared plus 2ab plus b squared. The second one is the difference. A minus b to the power of 2 is solved in this way: a squared minus 2ab has b squared. Okay, so we will expand each of these examples using the formulas. The first one is the sum, so that must be the first to the power of 2 plus 2 times the first times the second term plus the second to the power of 2. 4, that gives 4 plus 4x plus x squared. Now let's work with the second example. Here we see a difference, so we will have to apply the second formula. The square of the first minus 2 times the first times the second plus the second to the power of 2, that is 9b squared minus 2 times 3, 6. 6 times 5, 30, so that's minus 30b plus 25. And at last, the third example, this is a sum, so we will apply the first formula. That's 2a to the power of 2 plus 2 times the first times the second plus a to the power of 2. Here, we can eliminate the 2's. 2 divided by 2 gives 1. So we will get 4a divided by a to the power of 2 plus a times a squared plus a squared. So finally, if we combine like terms, that's 4 divided by a squared plus 2 times a squared. Here we will solve three examples about the square of a binomial. So let's see. The first one is, what's the value of x times y? So we will have to apply the formulas in order to expand each parenthesis on the left. The first one is x squared plus 2xy plus y squared minus x squared minus 2xy plus y squared equals to 28. X squared plus 2xy plus y squared minus we have to distribute the negative sign, so that's x squared plus 2xy minus y squared equals to 28. What comes next is to combine like terms. So x squared minus x squared gives 0. Y squared minus y squared gives 0. And at last, 2xy plus 2xy is 4xy. So finally, divide by 4, and you will get that the value of xy is even. Well, it's 7. Now let's see example number 2. We're told that p minus q to the power of 2 is 25. If we apply the formula, p squared minus 2 times pq plus q squared is 25. Don't forget that the value of pq is 14, so we will substitute that here. P squared minus 2 times 14 plus q squared gives 25. Now, p squared plus q squared minus 28 is 25. So finally, p squared plus q squared is 53. Wait a sec, that is not the answer. We are looking for the value of p plus q to the power of 2. This is what we want to know. So remember that p plus q to the power of 2 is given by p squared plus 2pq plus q squared. I will rearrange this sum. This is p squared plus q squared plus 2 times pq. And I know that p squared plus q squared is 53. And also, I know that 2 times pq is 2 times 14. Don't forget that the value of pq is 14. So at last, we get 53 plus 28, and the sum gives 81, which is the answer. This is the real answer, 81, choice D. Okay, this is quadratic factoring, another popular type of factoring methods shown in the SAT. This is a quadratic trinomial where a is 1. Now, if a is 1, then the polynomial has this form. In order to find the factored form of this, we will apply the product sum method. That is the following. X squared plus 4x plus 3 can be factored as x plus some number, let's say some number m, times x plus some number n, where m times n is 3, the constant, and m plus n is 4, the coefficient of x, 4. That's why it is called the product sum method. So you have to think of two numbers with a product of 3 and a sum of 4. Now, these two numbers are 3 and 1 respectively. So the factored form will be, I'm going to write it down here, x plus 1 times x plus 3. Because 1 plus 3 is 4 and 1 times 3 is 3. The same here, you have to think of two numbers with a product of negative 30, the constant, and two numbers with a sum of 7. Okay, so I know that minus 10 times 3 gives negative 30, and also minus 10 plus 3, okay, could be, let's see, 10 times negative 3 gives negative 30, and 10 plus negative 3 gives 7. So the factored form is given by x plus 10 times x minus 3.